Audience, welcome to the 3D Print Authority podcast. This is a place where we come together to have a transparent and no BS conversation about 3D printing and technology. My name is Adam Fosnot. I am the host of the podcast and also the president of Power About 3D. Joining me is Sarah Jordan from Fabrisonic. Sarah, could you just introduce yourself to the audience?
Yeah, I give a quick overview. So I am the product manager here at Fabrisonic. We are a 3D printing company in Columbus, Ohio. Actually, we are in the lease space on the campus of Ohio State University,
Okay.
Ohio State University. And my background is as a metallurgical engineer.
Okay.
But I do a little bit of everything.
Gotcha. Very cool. I think I've met one other metallurgical engineer before. He was from Germany and was just like one of the smartest people that I've ever met. Just knew so much about so many different like nuances of engineering. It was super cool. But Fabrisonic does metal 3D printing, so having a metallurgical engineer on the team is probably a very good thing. How did you first get started in 3D printing as a whole? Did you have any experience before your current role?
Yeah, so I started out in 3D printing about 6 years ago. I think I'd heard of it before then. Actually, if I go way back, I was given an opportunity to study it in grad school, like in the early 2000s.
Okay.
And at the time, I thought that technology is not going anywhere. How wrong I was, and I kind of kicked myself for that. But in about 6 years ago, the Youngstown Business Incubator had a business pitch contest around 3D printing called AMP 3D. I don't know if they may still have that. I'm not sure. But my background was actually heavily in casting technology.
Okay.
And it became very like obvious to me. I'm like, oh, we need to like better merge casting with 3D printing. So pretty much pitched an idea to merge FDM with a niche type of casting called wash foam casting. We were one of the finalists in the pitch competition, but we ended up not getting any funding. But we kind of went off and started doing our own trials and whatnot with that technology. But eventually it has led me to Fabrisonic, which is completely unique, different kind of technology, actually probably different than most people are used to at all because it's based on ultrasonic welding.
Yeah. I guess that's one of the biggest reasons I thought it would be cool to bring you on is because most people think metal 3D printing and they think DMLS, powder beds, the whole thing. I haven't heard of anyone doing ultrasonic welding based printing before. How long have you been with the team?
So I've only been with Fabrisonic since last September, so almost a year now. So I know enough to be dangerous.
Yeah. And then as a product manager, for anyone who doesn't know, what are your responsibilities?
So we're a small business and kind of startup and growing rapidly. So I don't know that my job title necessarily matches like what a product manager would be at like a big company. Like I used to work at Emerson, and there a product manager was kind of the liaison between all the different parts of the organization: sales, the customer, quality, operations, engineering. That was like big company product manager. But here it's kind of a lot of all kinds of things. So I do stuff with like writing government grant proposals, SBIRs. I talk to customers, marketing, communication, literature, work at booths. I am in charge of the quality program, although I think that's probably not a normal job, but that's just because I have a background in quality. And just generally like looking out there for like what is the market needs that like our technology could potentially address in novel new ways, because we are kind of an enabling technology.
Okay. Gotcha. So as a startup, it totally makes sense that you would have lots of different kind of roles and responsibilities. Um, to your point, where do you see it fitting in more often than not?
Our technology?
Yes.
Yeah, so UAM is kind of different because it is based on a solid state process, ultrasonic welding. So it doesn't involve any heat or melting like most of the other processes. And that gives it kind of, I'd say, two key capabilities that are different. So the one is we do a lot of work with embedding things in metal that would be damaged by heat. So
Okay.
things like embedding sensors, embedding electronics in like packaging. We've even done work embedding liquids, which I think is a little wild, but apparently, people ask you to do something, and you're like, sure, okay, we'll try that. And then the other part of our technology is it's hybrid.
Okay.
So all of our machines are built on a CNC machining platform. So they have the capability to alternate the additive and subtractive, and that's how we actually get the material complexity.
Okay.
Like UAM is a sheet lamination process.
Gotcha.
It falls under that part of the ASTM standard. So we're laying down either um, somewhere between 1/2 inch wide tape to a 1 inch wide tape, or even like much wider sheet of material in each layer.
Okay. Gotcha. So two things that are super unique compared to other metal printing companies, especially. You're using sheet lamination, which I feel like I might have seen in metal at one point, but I think is usually used for like paper printing in like full color. I'm not sure most people use it anymore. Um, and
Yeah.
you have a hybrid machine, which again, super unique.
Yeah. I know Impossible Objects, they do sheet lamination with composite material, which I think is pretty interesting. And I'm not super familiar with, like, I've never actually seen their stuff but I am familiar that they're doing that in the additive space. But yeah, it's not the most common process for sure. And the the hybrid nature is kind of where we get very complicated geometry, but it's also where we get what's kind of unique about this process is precision. So we get machine tolerances for surface roughness and just geometrical precision.
Yeah. Which again makes you super unique compared to most metal printing processes where you're dealing with like plus or minus 5 thousandths of an inch oftentimes, or you're dealing with casting like surface finishes. But when you pull a part off the machine, I'm guessing it has like it looks and feels like a machined part.
Correct. Yeah. So that is definitely unique. Don't we can do some kinds of post processing, although we tend not to. I mean, 'cause that's just adding time and cost.
Sure.
I mean, some people will still want that, but it's really going to depend on the design needs.
Yeah. So tell me more about your process. Like you start with a CNC platform, and like if I'm going to print a part, what's the first step that the machine's going to take?
Well, the first type is we do start with some kind of build plate material, whether it's um, just aluminum plate or whatever. Sometimes we will use other things like a casting. We've started recently doing something that we call synergistic additive. So that the idea there is that we are doing our process on top of another additive processed part,
Okay.
and then kind of getting the best of both worlds, and getting something that is, you know, not just additive of the two processes, but like even better. So we've done work where we take like a powder bed fusion part and embed a sensor and do some cladding on the surface, or things like that, or do UAM with material that is cold sprayed.
Okay.
Um, like our kind of philosophy there is that you don't necessarily, like, you don't go to a machine shop and just see, say drilling machines. You'll see lathes and drills and grinding and broaching and like all of these things. And so the idea there is like, well, maybe one day all of the metal additive manufacturing shops will have like, you know, 6, 7 different kinds of machines and use
Yeah.
them together, and a greater network or um, of different capabilities. But once we get the build plate, then I mean, it's pretty straightforward. Set up the parameters of like, well, how many layers are you going to do, and the way, I guess I haven't really gone into like how the process works. So ultrasonic welding is based on the fact that metal want to share electrons and just join with each other.
Okay.
But the reason that doesn't happen, with just, metal that's sitting around, is that all metal at the surface has a very thin oxide layer. So, if you put aluminum next to aluminum, it doesn't just stick. But the way the process works is we have this device that it basically vibrates back and forth at about 20,000 hertz, or we have a smaller device that actually goes at 30,000 hertz. And while applying pressure, that scrubs back and forth and knocks the oxide layer off. And then you have these on either side of the two layers, and then those metal atoms can then grab and start sharing electrons, and then you will get what's called a solid state bond. And I mean, essentially it is a type of friction welding that's happening. And so we do that, and that's what happens in each layer, and then you can just build up material.
Gotcha. So then you deposit it in like a tape off of a roll, and I'm guessing it gets pushed onto the build plate and then vibrates really fast and creates that bond.
Yeah. Now, sometimes we'll do it with the tape, and that's definitely faster option. Depending on what it is, then sometimes we'll just lay down sheet material that's a little bit more manual, and so it's not perhaps as fast, but sometimes there are design reasons where that's a superior option.
Gotcha. What build volume do you typically work with? Are we talking like handheld size parts, bigger, smaller?
So that really varies, but people are probably surprised that our largest machine actually goes 6 feet by 6 feet by 3 feet. So that's actually pretty large. And then we have 2 smaller equipment models. We do manufacture equipment as well. And I would say most of the parts are probably not that big. They're, they can really vary, but they might be like, I don't know, around a couple feet. Sometimes people want really small things made this way for their purposes. Unfortunately, a lot of the cool things we do, we can't actually talk about, which is always,
super fun.
Yeah, we do super fun stuff we can't talk about.
Yeah, but so in theory, you could print something that's 4 feet long. Like, it's not limited by the process.
Right. And actually, in some ways, we can, we have in the past, I guess I've been told, this is before my time, build things larger than the machine's actual build volume, although that is a painful kind of process, because you're basically, having to have material be outside of build plate and have to have supports and things like that. But it can be done, and we're actually in the process now. We're working on an SBIR with NASA, with the goal is to remove the CNC machine and be able to do this process with just a robotic arm, and then essentially, remove the envelope restriction. So that, if the robot can move there, then you could keep going.
Gotcha. Very cool. So you mentioned NASA. Are most of your customers, partners in kind of that aerospace sector, or where do they come from?
Definitely a lot of them are in aerospace, but we've done a lot of work with automotive. We've done work with, I guess, oil and gas. Just a really wide variety of industries come to us with different unique problems that the solid state nature of this can help with, because we can build all kinds of different new metal composites by if you can join together and build up pretty thick layers of material of all kinds of different combinations that really can't be made in other means.
Yeah. So what types of materials are you usually working with?
really a wide variety. We do aluminums a lot,
Okay.
like probably in a lot of different grades there. I'm actually working on a new materials design guide that we've done work with, I think, 18 different aluminum alloys,
Okay.
which is, I think, more than is typically possible in the other processes. And at least with aluminum, we think like if it can be rolled into sheet material, that it would work in our process if
Okay.
somebody needed a new alloy. But other things, we do coppers a lot, steels, even more exotic things like tantalum, molybdenum, just just all kinds of things, really.
Yeah, but even just hearing that variety uh, is again super unique when you look at what is the most common metal 3D printing. It's DMLS 316L
Yeah.
typically,
Um,
and that's what people are usually stuck with. So just having that broad range and being able to make multi metal parts hugely unique and different.
yeah. The other thing, so we've also done work with amorphous metal foils, some metal matrix composites that have where they're like, say, aluminum with Nexel fibers or silicon carbide or something like that in them. And even in some cases with ceramics, as long as they can be metallicized on the outside, that this process can join them together with. So yeah, definitely a pretty wide diversity of things that are used.
Gotcha. Very cool. Um, I'm struggling to wrap my head around this solid state bond between two pieces of metal. So there's no heat involved. How strong is the bond? Like compared to like traditional arc welding or casting? And I guess the reason I'm asking is because in plastic FDM 3D printing, parts aren't isotropic, right? They have kind of like that wood grain, um, imbalanced strength nature to them. Does your process have something similar, or is it like uniformly strong throughout the part?
Yeah, so I understand what you're saying. So um, I guess there's a couple things. So first, sheet metal itself is rolled and it has some um, anisotropy to it already because of
Yeah,
the rolling process, right? Like the longitudinal direction in a piece of aluminum sheet is not going to have exactly, I mean, it's going to be close, but it's not going to be exactly the same as the transverse direction. So you already got like the feedstock starting out that way. But although, the testing we've done is like, all right, it's pretty close.
sure.
Um, and then in the Z direction, we tend to see about a 20 to 30% drop off in the mechanical strength compared to the feedstock. Um, that's primarily because in a given location where it's bonding, then it's equivalent. It's joined. It's just that there are remnants of that oxide that do get embedded in the material. So that causes, some level of a drop off in the Z height.
Okay. I feel like you're trying to explain it in a very simple way, and I appreciate that so much.
Well, I'm also trying to like not be like too metallurgical, and you're like, what are you talking
Yeah,
about?
yeah.
Dislocation theory? What?
And a lot of times, I think when I'm talking to someone who has like a very specialized, like high level of knowledge in an area of engineering, I'm sure you could like talk for 30 minutes just on on that one question. But I wouldn't understand most of it, so I appreciate that. Even when you say 20 to 30% decrease over the stock material, when I look at all of 3D printing, that's still not bad. Like when I look at plastic FDM 3D printing, a lot of times in the Z direction, a part is half as strong as it would be along the layer lines. So it's still, I think, respectable in a way, especially given kind of all of the advantages of your process.
Yeah, yeah. I think it's not bad. And we're actually in the process right now. I don't know if you knew this, like we got funded recently for American Makes project proposals. So
Okay.
it's targeting it's very specific to 6061 aluminum, but we're working to develop the um, design allowable data for the MMPDS handbook with that, and so we will have public statistical data on all of these properties for that material. Because what ends up happening a lot of these times is like we have some data, but then it's like, okay, well, we can't necessarily show it because it was paid for by a particular customer.
Yeah.
Um, yeah, so that's in the works. I think it's got to be wrapped up and finished by May, so it's a pretty fast project.
Gotcha. Well, congrats on the funding. I hadn't seen that yet somehow. Um, but yeah, I think it's really cool how America Makes is able to kind of sponsor public research compared to in a lot of areas for a lot of companies. Um, it's all locked up under NDAs and then patents, and then like there's not a ton of that just sharing information about something that's really cool. Um, Looking at like different projects you've worked with or like just parts that you've printed, are there any that were like really cool applications that you are able to talk about?
Um, I think the current NASA project for getting UAM so we can print in space, I think that's pretty exciting. It's only in the phase one, but basically the project is to show proof of concept that this is going to be able to repair holes in space. Since there's like, a lot of stuff flying around up there,
Yeah.
um, space debris and things like that. So I think that is a pretty interesting project uh, to have that as application. I think everybody's, yeah, 3D print in space. That's really cool. What else is going on? We also, although the paperwork's still kind of in the process, but we recently also, a NIST SBIR was awarded to actually a materials test lab in your neck of the woods
Oh, no way.
that is working with us to um, there's a test method that has kind of grown up with the UAM process that we call the push pin test,
Okay.
and it's intended to test delamination. All the current delamination tests were designed for coating tests, which is
Okay.
like a single layer of material.
Hmm.
So this test is designed to test a multiple layer structure and see if what the failure point is due to delamination or if it's due to the material strength itself, which you would prefer it not to delaminate.
Right.
So this project is we're trying to gather a bunch of data with other kinds of materials to see if this would be something that would be good for the general additive community, if that would make sense to make it into a standard method rather than it just being, in like the niche ultrasonic additive world, which is where it currently is used.
Yeah. No, I think every time I'm like at a conference, the topic of uh, engineering standards for 3D printed parts comes up, and it's always discussed as just something that no one's ever paid attention to before, as if it wasn't important. Um, and to your point, I think having tests specific to additive parts would help a lot, kind of progressing that initiative so that people can start using it for more and more things.
Yeah, yeah, we've been trying to drive that because like we use this method ourselves, and then people are kind of like, what do you mean this is like your homemade
Yeah.
test? You're like, well, this is how we know if it worked or not.
Well,
Yeah,
I'm sure it's homemade because I've never heard of it before. Like tensile
yeah,
strength tests, 3-pin deflection tests, like those are the normal ones.
Yeah, I mean, it's in the UAM literature, like it's been like published, I don't know, like 10 or more years ago. And from my understanding is all the places that have UAM machines, like that's what they will use to, check their, is this actually adhering to the good bond,
Yeah.
across all the layers. So so that's why we're kind of working on that is, all right, so we want to run tests with, some SLA parts, FDM parts, actually even I think we're planning to do some just normal, composite, like not additive parts, just like other parts that we know are lamellar structures and see what kind of data comes out of that.
Yeah. Very cool. You mentioned other places that they have UAM machines. Um, do you guys sell machines? Do you sell parts? What's kind of your strategy there?
Yeah, we do both. Um, what do I want to say? So Fabrisonic originally was, targeting the idea of just selling machines and kind of, you know, over time discovered that nobody's going to buy a machine blind.
Okay.
So we tend to do kind of the prototyping process, maybe smaller volume production, and then at some point, well, maybe they don't. Maybe they just want us to keep making the parts. But at some point, a lot of times people will then buy a machine. And in some cases, people will buy a custom machine that is targeted towards high volume production.
Okay.
What we found is that you can have a totally flexible machine that can make anything, but that's not going to make you automotive volume and automotive price parts, right?
Gotcha.
You need a custom design machine that will do that. So do a little bit of all of that.
Yeah. Interesting. And again, I think that makes you so much different from a lot of the other printer manufacturers. Like lots of people make machines, lots of people will sell parts off of those machines. But I think it's really rare that someone will kind of bridge that gap between printer manufacturer and custom equipment manufacturer. But I imagine that by doing that, you're able to uh, just create better results for the people that are using those machines.
Yeah, I think part of it's because we are in this niche. So,
Yeah.
um, if there, it might be different if there were, I don't know, 80 UM companies out
That's
there, but
true.
yeah, we're kind of the world experts at this.
Yeah. Um, I'm remembering something I think you mentioned at the beginning of our talk where you talked about embedding sensors into prints. So, why would you embed a sensor into a print? What type of sensor would you embed? Um, just can we dive into that application a little bit?
Yeah, so all kinds of things, really. Um, if people are interested in embedding, say, strain gauges within an actual part to kind of study the forces that a given part might be seeing, there's kind of interest around that with, like, say, digital twins. So we've done work there with like making like, you know, I don't know, drone brackets and struts and uh, just a variety of different kinds of parts. And so some of that's just around like researching the phenomena that are in the normal parts.
Okay.
Um, but sometimes, embedding thermocouples is of interest to people because, like, studying what the parts are seeing and, say, like a heat treat furnace. Another thing we have in development, I guess what do I want to say around this? Uh, so this started out as a DLA SBIR, and it's in the process of being commercialized.
Okay.
We have a product, actually, we call the Smart Build Plate. So it is designed for powder bed fusion systems, and it has a embedded fiber optic in the build plate that can then show you the stresses and strains that are arising through the build process. It can show you, like, if the part cracked off the build plate, if it's starting to get, um, you know, basically if the build is going awry, and tell
Okay.
you this, which people seem to see as valuable, since those can be really lengthy processing times. And if your part is messed up at day one, you'd rather know than not find out for like 10 days, and then you pull it out and you're like, it's messed up.
Yeah.
Um, so that is I don't know, there's just various reasons people want to embed sensors in metal. Sometimes it's just for protection too.
Okay.
Um, if you're going into, like, orbit or things, they want to protect things from the elements or radiation or whatever.
Sure. No, that's kind of like a few, I think, really cool examples of how people would use it. Naturally, I really like the build plate for powder bed fusion. Um, I think a lot of people don't realize that a build on one of those machines might take a week or 7 days. Um, and I think it's cool that you're using one 3D printing process to improve another 3D printing process.
Right. Yeah. Yeah. So there's definitely, I think that's pretty interesting as well, to try to do that. And I also, like, there's a lot of work with powder bed fusion trying to, um, have in process monitoring at the level of where the like the top powder layer.
Yeah.
Um, but the problem is stresses can happen and they kind of build up over time. So that's kind of the point of our smart build plate, is it's not just the process monitoring of the given point defect of where you're putting on the powder, but it's what's the whole part seeing, and how does this happen, when you're like hundreds of layers up from, and it's like now at the bottom it has too much stress and cracked there or something.
Yeah, definitely. Um, when you look at the speed that you guys build parts, how does it compare? Is there like a number of, like, we do X cubic inches per hour? And I'm sure it varies between different materials.
Yeah, yes, exactly. It's going to vary, and it partly is going to vary on whether we're doing sheet or tape, but it can be actually up to as fast as 40 cubic inches an hour. Although that's probably, that's a pretty aggressive rate.
Okay.
Probably 10 to 20 is probably more reasonable.
Okay.
Um, and then the other thing we've done with some of the custom machines is we just, like some of the powder bed processes, you install multiple heads, and that can drive up your efficiencies in the same machine.
Yeah, definitely. Um, so I'm putting you on the spot here. So if you don't
Uh-oh.
have an answer, say I want to print an aluminum standard size baseball bat with tape. How long would it take?
I don't know. I think that might take some design efforts. So I think that
Okay.
um, wouldn't be perhaps I don't know. That would be interesting.
Okay. To,
Because the problem with the aluminum bat is so thin on the inside. Um,
gotcha.
and we do use support material in our process, but that would take a lot of support material. So that might be an interesting, challenging part.
To be fair, I don't know of very many metal printing companies that could even like come close to doing that, but I figured it was
Yeah, that's
worth a
that's your
shot.
go-to that's your go-to challenge part. Like, can you
Well,
make
because it's big, and because like I would never ask a DMLS company to print a baseball bat. One, it would be horribly expensive. But also there are no machines that can do it. So also very few DMLS machines that even print aluminum, and usually it's like a weird aluminum alloy. So like
yeah.
if anyone could do it, it would be you.
Yeah. I'm not actually sure, how are they made now? Are they die cast or something? I don't
I
know.
assume they're die cast. Yeah, but that's a great question. If anybody watching knows how aluminum baseball bats are made, there's probably a how it's made. episode
probably.
about this. I'll just look it up myself after we're
I
done
know.
talking. But you
Leave it
mentioned
in the notes.
you mentioned support material. How does that work?
So for some of the complexity, since it's sheet lamination, we will alternate the machining and the additive process. But if we have a big gap, just like in other processes, it's going to sag inward and over that, channel.
Yeah.
So we have a material that is a water soluble material that we've developed. It's patent pending, but that we put in the channel.
Okay.
And to kind of fill it in and give, I guess, some level of back pressure so something doesn't collapse inward. And then once the process is done, we will use water to dissolve it away.
Yeah, and I guess
So I
because
think it's kind of like some of the polymer processes have water soluble
yeah, but
material.
because you don't have any heat, that's something that you can do. Versus like if you were uh, laser welding or something where there was a high pinpoint of heat, having something that was water soluble would be really difficult.
Yeah, probably at least the material we use probably wouldn't work in that process.
Gotcha. Cool.
Um,
Um, I would like to wrap up with some like kind of higher level questions. So there are no right or wrong answers. Um, but when you look at the whole wide world of 3D printing, what is one thing that you don't like about it? So maybe you don't like how few materials are available. Maybe you don't like that it's generally pretty slow. What do you think?
hmm, that's an interesting question. Um, I guess, for my metallurgical background, I think there are a lot of things out there that are not correct
Okay.
from a metallurgy standpoint that are said and like marketing things. I mean, whether it's considered marketing hype or just, people don't understand metallurgy. I
Yeah.
mean, I guess lots of people don't understand metallurgy in general, but like people will call things 6061 that are not 6061, for instance.
Gotcha.
6061 is a rot designation. And that's just kind of like one of my ongoing pet peeves is that if it's not rot material, it's not 6061 or
Yeah.
7075. And in UAM, we actually use rot feedstock, so it is 6061. But the other additive processes, the additive metallurgy and the microstructure that's happening is it's not necessarily worse. It's just different, and the material is different, the alloys are different, the properties
Yeah.
are different. So just acting like, oh, now we can make the same thing that we've always made. It's like, I don't know about that.
I think your example is so specific. I would never know. So you taught me something today that 6061 is a raw designation. I have never looked into it in that much detail. Um, but also, it's a specific example of, I think, a larger issue is that sometimes it's marketing, not understanding like the deep technical aspects of it. But regardless, there's a lot of things that make 3D printing confusing. Which is one of the big goals of the podcast is just to like have an honest conversation and not overhype things if they don't need to be. Um, so outside of your products, what you're doing with Fabrisonic, what is one thing in again the 3D printing world that you're really excited about? So this could be a trend, a technology, something that you want to say more of. I've gotten everything from like
Hmm.
generative design to 3D scanning, which is close enough. I'll allow it. But what do you think? What's one thing that you're excited about?
Hmm. I think the thing, and the part of the reason I'm in the additive space is like I like all the innovation. I worked in manufacturing for a long time, and there's a lot of attitudes of like, this is the way it's always been done. Um, so I think that that is just the benefit is, all right, you got to think differently, you got to design differently and consider new capabilities. And there's lots of problems to be solved. So, to be able to think of new ways to solve them. And it's not that, I mean, some of these things could be solved with traditional processing techniques, like machining or casting. It's just, you know, they're really stuck in the past in some ways, and sometimes that's due to purchasing processes and not necessarily technology. But additive like demands that you change.
Yeah. I have walked many manufacturing floors and talked to many engineers in charge of processes. I was like, well, what if we printed this? What if we printed this? Oh no, we can't do that. We can't do that. And then like there is so much of that mindset of like, well, we've been doing it this way for 60 years, and this is just how we're gonna keep doing things. It can be definitely frustrating, but it is different in 3D printing. And I think there is so much innovation in the space, especially in metal compared to plastic. Um, we're having more and more metal printing companies start to uh, have IPOs and developing different technologies. And I think you're right. I think it's a cool space to be involved in. Um, Wrapping things up. Um, if Where can people find you? Where can people learn more about Fabrisonic? And then if there's any like specific actions you'd like the audience to take, now's your chance.
Well, our website is fabrisonic.com. We have regular blog articles that come out about the different things we got going on and what we're doing. I guess feel free to reach out to me on LinkedIn. And, if you have any questions about UAM, give me a shout.
Awesome. I hope the audience will take you up on that and ask you lots of questions about UAM because it's so different and interesting. Thank you for taking the time to chat, and I will look forward to connecting in the future.
All right, that sounds good. Nice talking to you, Adam, and maybe sometime we'll actually meet in person since you're not that far away.
Absolutely, we're so close. I'm planning a trip to Columbus to visit a few people, so I'll add you to the list for sure. Audience, thank you so much for tuning into my chat with Sarah from Fabrisonic. I really hope you caught on to some of the really unique things that they are doing with metal additive manufacturing that other people aren't doing. Specifically, aluminum, lots of different types of metals available, multi-metal parts, embedding sensors into their parts, so much different from kind of the status quo of DMLS metal 3D printing, and I think it's such cool technology and very exciting. If you haven't already, make sure you subscribe to this channel wherever you might be watching or listening. That way you don't miss new episodes when they come out every single week. Happy printing.